All right, I'm going to go ahead and get us started. Thank you, everyone, for joining us today. We're thrilled to have you here for an exciting and informative session on Retrieval-Augmented Generation. My name is Skip Everling. I'm the Head of Developer Relations here at Kolena. Today, we're going to be diving deep into this world of RAG systems. It's this groundbreaking approach to enhancing the capabilities of large language models that I'm sure all of you are becoming familiar with. Whether you're a seasoned AI professional or just getting started, this webinar will equip you with some valuable insights and practical knowledge to elevate your AI projects. Before we get started, just a quick word about Kolena. Kolena, we're committed to advancing the quality of AI models through rigorous and systematic testing. Our platform provides comprehensive tools for evaluating and refining machine learning models, ensuring they perform reliably in real-world scenarios. So from detailed performance metrics to robust evaluation frameworks, Kolena helps AI teams build models that they can trust. We are also very excited. We have our AI Quality Conference coming up in about 1 month from now. This is our first conference. It's going to be a fantastic opportunity to dive deep into AI quality, all angles, all types of use cases. There's going to be a lot of industry experts there. We have a stellar lineup of speakers from companies like OpenAI, Google, Weights and Biases, many more. Really looking forward to that event. At the end of the talk, I'm also going to share a discount code for the tickets. So I'll definitely want you to check that out if you have an opportunity. All right. So for today's webinar, essentially, we're going to be covering how these RAG systems are becoming widely used. We're going to talk about the fundamentals of how RAG systems work, what their architecture looks like. We're going to go through common pitfalls and how to avoid them. We're going to talk about evaluation metrics, a lot of the new metrics that are being developed to evaluate this new type of approach. And then we'll go through an example of how we're applying evaluation to a RAG system that we developed on Kolena's documentation. At the end, we're going to have Q&A, live Q&A, where Andrew, our guest speaker, will be answering some of your questions live. So feel free to use the Q&A applet here in Zoom to answer your questions. We also have some members of our research team standing by as well, and they'll answer some of your questions written in the Q&A. All right, our guest speaker today is none other than Andrew Shi, our CTO and co-founder here at Kolena. Andrew has a wealth of experience in building and deploying cutting-edge AI systems, and he's here to share his expertise on how RAG systems can transform your AI models by improving their accuracy, robustness, and overall performance. Fun fact, he can also say, my cat has 3 houses in 12 languages. So maybe we'll get a demonstration later. Without further ado, let's get started. Please join me in welcoming Andrew Shi. Hi, Andrew.
Hey, thanks, Skip. Let me go ahead and switch to sharing screen here. Hopefully everyone can see that.
Looks good.
Great. Yeah. I'd love to, super excited to be here, super excited to jump into things. Before I jump into kind of my own interest slide here, I do want to give major props to the Kolena research team, especially Saad, who's also on this call for really doing a lot of kind of the analysis and putting some of these things together. I'm kind of giving a quick summary and like of kind of a lot of the work that they put together. So very, very happy to be working with them and to be talking with everyone today. Cool. So quick intro about myself. As Skip mentioned, I'm the CTO and co-founder of Kolena. My background has kind of just been in tech for north of a decade. I started at Palantir, worked there for about 8 years on all sorts of systems, from QA processes to deployment infrastructure to working with the government on like iterating on the software. And so that was a very valuable, informative experience for me. Afterwards, I joined Synapse Technology, where I met the other founders of Kolena. We built and deployed AI systems in security and threat detection spaces. And most notably, kind of worked with the TSA to do threat detection on X-ray scanners. Afterwards, I worked at Rakuten. I led their mobile AI platforms engineering team, and so kind of built out AI infrastructure for scaling that up to large large models and also handling kind of the deployment and infrastructure, and as well as kind of really running into problems where like running into pain points with validating and ensuring high quality models. And uh, currently, as mentioned at the start, working as co-founder and CTO here at Kolena. Um, Outside of that, some fun facts about me in case you happen to find me at the AIQCon and like want somebody to break the ice with. I'm an avid runner. I generally do like north of 40 miles a week of just like I find it very calming and relaxing, and kind of helps takes the mind off thing. I love puzzles. I super into puzzle hunts and that sort of stuff. And don't get me started about food. I will happily eat all sorts of cuisines. Cool. Um, let's jump into things. So the agenda that I have prepared for y'all today, as Skip kind of mentioned, we're going to go through kind of an overview of RAG systems, just to make sure that we have the same common ground of like, what is a RAG system? How does it work? What are the components? Because that also sort of informs kind of the failure modes in RAG systems, kind of how they could fail, like how do you actually evaluate if your RAG system is performing well, as well as kind of mitigation strategies and like optimization here. So like once you understand these failure modes, how do you best handle them? And then lastly, we'll go through an example of how we evaluated our RAG system on our own Kolena documentation, how the pitfalls and things that we noticed with kind of different, comparing different RAG systems, with different components. Quick summary of that, and then the Q&A as Skip mentioned. Cool. So really quickly, just to get things out of the way, what is RAG? RAG is Retrieval-Augmented Generation. It's a way of sort of enhancing the output of a generative language model. Basically, typically like with an LLM, without like RAGing this as part of the process, you just ask it a query, it gets sent to an LLM. The LLM kind of is trained on just a giant corpus of information. So you can think of like ChatGPT was just trained on basically the internet and many pages in its various forms, and then it outputs an answer for you. And for the most part, that works great if you're looking for things that involve kind of general conversation or like knowledge that is unchanging for unchanging or not very specific. But RAG, um, retrieval augmented generation, kind of uses additional information to pull from a very specific knowledge store. And the value here is that not only do you get the power of the LLM, the generator to answer your questions, but you get to pull on kind of a very specific knowledge base, be that a vectorized like embedding store from I have my own documentation, or I have my company's particular information that I need to provide, or here's my patient database in a medical context, and so I can look up information about these particular patients, or I have financial information that is constantly changing and constantly being updated, and therefore, as my knowledge store is updated, my generator can't necessarily keep up with that. But with this retrieval type system, it can grab that information, pass it as context into the generator, and sort of combine both the query and the relevant information together to get a more accurate, more correct answer. So quick summary of what that is. Kind of as a result, we're basically using any sort of retrieval system, like is kind of valid for this, that can range from like a single passage, like even searching the entire internet, or searching like a particular patient database, or like a domain specific database. But most commonly, and kind of the architecture that I'm sort of assuming here, is that it's a vectorized database, and you've taken a corpus of documents and kind of chunk them and thrown them into that database. Um, Sorry, this is kind of just this bullet points. This basically talking about vectorized databases, and really the retrieval part of this process, especially evaluation, is basically part of information retrieval as a general study. And so that's something that sort of predated kind of the recent rise in LLMs. It's there's already kind of like a lot of academic study about it. There's rich literature, and so there is kind of a side of this retrieval that is able to, like, people are able to analyze and evaluate with great confidence. This is kind of an extended diagram of RAG as a system, talking through kind of just more breaking it down in a little bit more details. As mentioned previously, kind of what in most contexts for a RAG system, you're taking a document corpus of like could be just a set of pages, could be a wiki, an internal wiki of information that is not necessarily generally available. You're running through kind of a chunking process and of breaking those documents down into kind of relevant, meaningful chunks that can be passed around as context. Like, you're not going to pass the entire corpus around into as context into the generator, but because you're limited in terms of like context length, and that chunk then becomes the sort of the context that you pass around. You extract embeddings on it, you store it in a vector database. You can think of like face or pinecone, etc. And then that vector database is used along with the query to retrieve a relevant chunk of basically this information. Looks like it's semantically similar. This is the relevant chunk that gets passed to the generator along with the query. It gets wrapped in a prompt of like providing context of how the LLM should be sort of handling this information. Pass it through the LLM. You've got your answer. Cool. So last little slide on RAG before we talk into a little bit more detail on evaluation. But basically, RAG has sort of become omnipresent. It's almost the new hotness in the space right now, where it's prominently used most commonly, I think, in chatbots of like, hey, I'm talking to a particular company. That company has domain specific information, and that like we need to surface that for things like just like, hey, I'm running into this problem. How do I actually handle it with your system? Content creation, documentation, kind of sort of our example today is kind of surfacing information and documentation. Not going to go through all these bullet points, but like there are basically a ton of applications that require accessing domain specific or up-to-date information that can be augmented and leveraging like LLMs accordingly. Cool. So let's talk through the meat of this this webinar. Failure modes for RAG systems. Cool. So the way I sort of think of it is that there are the ABCs of failure modes, and I kind of have them backwards because in terms of importance in some ways, the C here is correctness, where basically, does my RAG system actually give me the correct answer? And really this, because this RAG system is a combination of a retriever and a generator, that failure can come from either the retriever side, if I'm not passing the generator the right sort of context, if I'm not retrieving the most relevant documents, if there's a lot of noise or contradictory information in the documents that I retrieve, if my chunking is poor, and they're like that the right relevant piece of information is lost within kind of a giant chunk. Those are all sorts of failure modes for the retriever side of things. On the flip side, for the generator side of things, basically it's assuming that, hey, how robust is the generator to kind of minor slip ups on the retriever side? So if like there's extra noise in the context, how robust are we? How robustly are we handling this? Are we using all the information that we are actually retrieving? So let's say even if the retriever is running perfectly, if the generator is kind of not able to process that well and turn that into a meaningful answer, that's failure on the generator side. And just like the format, or like how much detail like the generator is actually really going into with processing kind of the context that's been retrieved. Yeah. So number two, I think, in like the main sort of failure modes for a RAG system is just the behavior overall. Like when you implement a system like this, it's not solely based. It's not there's kind of a use case that goes beyond just, hey, I need this information, but oftentimes oftentimes like the system needs to have a presentable persona. And so kind of in general, basically the system needs to be able to sort of not answer or say, hey, I don't know, in situations where it doesn't have that information. So not falling back on like a hallucination of saying, hey, this answer is not in this in the context that was retrieved. I'm just going to give you a random answer because I'm outputting tokens one by one, and this one seems like it makes the most sense to throw in here. Um, at the on the flip side, when the context is present and relevant, then like the rack system should be answering. I think that's pretty straightforward. But also, depending on the application for the rack system, you'll want it to behave in different ways. And so one is style of response. Basically, what's the tone? What is the length of the response? What's the formatting? If it's a chatbot, does it actually resemble chat as like something that's actually presenting like chat information? I wouldn't want to read a giant blob of um, copy pasted from Wikipedia on a chatbot, even if that is the correct answer. I'd like it to be digestible. Does include valid citations when relevant, depending on once again depending on context. Um, you're trying to make sure that you're able to trace these answers from the system back to kind of the root of information. I find myself often using these systems, but also trying to make sure that it's not solely based on like a hallucination from the LLM, and making sure that if I do get meaningful information that I plan on acting on, just making sure that the source information is kind of aligned as well. Any sort of toxic or um, yeah, like any sort of um, toxic type behavior of like if there's any sort of maliciousness or harmfulness in the system, that becomes kind of a reputational um, uh, threat to your system. Um, and then PII leakage in general, like oftentimes these systems can be connected to personally identifiable information, and it's valuable to be able to provide summary information on, hey, I have a database of patients and I'm trying to understand COVID trends since 2019 and retrieve that sort of summary information. But if the system like retrieves, here are some COVID trends, here's a COVID patient, John Doe, uh, his like address and that sort of information that is part of the underlying data store, that becomes a HIPAA security threat. Well, a HIPAA threat at least. And so that's a huge risk of like a lot of these systems, and where a lot of thought has been put into kind of how to protect and guardrail your the underlying RAG system from leaking this information. Cool. So we've gone through correctness and behavior. The last piece is kind of just adversarial kind of attacks on the system. And there are kind of a few ways of like how you might jailbreak in an LLM type system. Basically thinking of someone who's trying to do something adversarial. For the most part, they're more on the reputational side of, hey, I made the system look a little bit silly. If I can sort of role play, do anything now, suppress like refusals by saying, hey, you can't use these particular tokens in your response, and therefore that steers the system more towards being able to, or like being more compliant with requests, etc. For the most part, those are, as I mentioned, kind of more reputational. It's embarrassing when you have someone on messing with your chatbot and getting your chatbot to agree to sell you a Chevy Tahoe for $1. But at the end of the day, like because these systems are not agentic yet, it's purely informational, reputational. Like, am I presenting them the wrong information? Um, there are some notable exceptions here where basically depending because there's a certain amount of trust that your users might put in your system, there's an avenue for kind of phishing and spoofing that can be inserted into kind of LLM type based responses. I think there's some examples on the internet of someone like inserting information into a web page, someone uploading kind of information to an LLM to say, hey, like give me a summary of this web page, and because of the injected prompt manipulation in that web page, it then tells them, hey, I'm sorry, the system's down, but like to bring it back up, please just go to this other web page and coordinate there. And then like that sort of lands you as like a security risk for an entry point for further malicious activity. So not purely reputational, but also potentially abusable by an attacker. So those are the three sort of main failure modes for RAG systems. The slide is just a quick summary of that in tabular form. Yeah, so bringing this back for kind of our more visual learners, I like diagrams as well. We're bringing this back to kind of just this overall architectural system here. And basically, because there are so many, let's get rid of that. Because there are so many components to this, basically each stage, each step of this has opportunities for failure. So from the query side, basically you can have adversarial prompt injection. From the retriever side, if you're just not retrieving the relevant documents, or there's too much noise in the chunks, or PII or private data is leaked in the chunks, like those are all failure modes on the retriever side. From the generator side, if the relevant information isn't used, if you're generating hallucinations, if the output format is not as expected, those are all sorts of failure modes. And kind of there's been kind of effort in the industry to sort of protect effectively these arrows of like, hey, here's the output of one system into another system. Can we check, like, can we add a stopgap in there to prevent a failure from really making it through? And so one is prompt standardization. So if the prompt itself, if the query itself is manipulated in some way or the other, then there are you can do some detection on that to try to sanitize the prompt. You can insert custom guardrails between the retriever and the generator to prevent data leakage, or other sort of recognize that, hey, this is not a good the ideal mode of operation, and we need to bail out one way or the other. And then there's like actually adding checks for the output format from the generator, like having a second, basically. There's been research done into having a second LLM, potentially not even as powerful as the first one, kind of, but like able to just focus specifically on doing these checks. And as a result, that like these are like sort of additions that you can add to your system to add a little bit more robustness and stability. The trade-off here is, of course, by adding kind of additional layers to the system, you're also exposing, sorry, not exposing, but slowing down processes. Like if you have an LLM at this last stage to check for the response and then bail out, or like bail out due to output format, or bail out due to data leakage, when you now have kind of a bailout condition in your system. But also because you're doing this sort of checking, like maybe some particular named entity recognition or whatever, like that adds latency. And for a chatbot, if it takes longer and longer, then people get more frustrated. So trade-offs there. Cool. So, sorry, let me take a drink of water. So let's dive down a little bit more into evaluation specifically, because the flip side of kind of adding these checks and guardrails is just running through your RAG system before deployment, making sure that you have a robust testing and evaluation framework to understand, hey, this is how my system performs overall, and these are the metrics that I care about, and we can validate that as we kind of iterate on the different pieces of it, update the prompt, update the chunking logic, update kind of the underlying database, changing the underlying LLM, et cetera. Our system continues to trend towards more robustness, towards more correctness, towards more more of the right behavior. So once again, going to kind of the dichotomy between retrieval and generation. On the retrieval side, we just want to make sure that we're retrieving the right context, that we're ranking them correctly when we retrieve them, and that like these contexts are actually meaningful and relevant. And on the generation side, like basically given that sort of retrieved context, is my answer factual? Is it actually using the retrieved context, or is it kind of generating an answer elsewhere based on other things that went in as input for the LLM? And is unexpected behavior actually correctly flagged? So if there is kind of misalignment between how you want the system to behave and kind of the information that is being generated, can the generator handle that and be robust to that? Well, oh, sorry. Um, uh, oh, sorry, I was um, but yeah, like quick summary here is just that in order to best handle this to best handle RAG failures, you want to be able to basically build out that testing framework, understand correctness behavior and adversarial kind of threats, make use of the metrics to understand like how well your RAG systems are avoiding each of those failure modes. So let's dive in a little bit deeper here for the metrics specifically, because I think the right way of doing this is just talking through metrics on the retrieval side and metrics on the generator side. Um, One thing before I jump into too much detail here is I think I see a good parallel here between kind of in traditional software, you have kind of your different layers of testing. You've got your unit tests, your integration tests, and your overall end-to-end type testing. And I kind of view testing or evaluation on rack systems in a similar light, where basically in general you want as many unit tests as you want. They're easier to maintain if you like reduce the scope, and it helps you understand kind of, hey, if I have a failure in my unit test, I know exactly where the problem in my code is. And so similarly for a rack system, you'd want to break that down as well into as small of a unit as possible. We've broken it down like at a high level into kind of retrieval versus generation, but you can sort of think of, depending on the retrieval system itself, there are different ways of just making sure that your vector database is performing in the way that you want it to, making sure that your chunking logic is operating effectively, making sure that kind of your chunks are the right sort of size, etc. And then also kind of the sort of integration end-to-end type testing, where once you put them together, black box, input, output, how does it work? So jumping really quickly into retrieval then, basically, as mentioned kind of at the start, information retrieval is one of the more well-studied fields of research. It's got more history than kind of recently LLMs becoming very popular and being like generative AI becoming more of a hotspot in terms of evaluation and analysis. And so we're kind of falling back on basically a lot of academic and industry work here for how well does a retrieval system work. And so basically you can kind of think of it as, hey, I have a corpus of results, and I want to make sure that the best results are surfaced at the top. That's how a good retrieval system works. And so in many cases, you've got kind of just your first stage retrieval metrics, and I think these are fairly standard for AI ML problems in general, of just for say the first n results, first 5 results, what is the accuracy of my retrieval? What's the recall of, if I have 3 documents that were relevant, how many of those 3 were retrieved? Of the 5 documents that I retrieved, how many of them were actually relevant to my problem? So the precision of that retrieval, and trying to optimize on those. In practice, precision's easier to use because you are limited in scope and kind of your retrieval count, but recall is difficult, harder, because you need to know every single relevant document and decide if it was retrieved or not. But then there's also more kind of ranking focused metrics as well. I think I'm going to focus on these last two, NDCG, which is normalized discounted cumulative gain, and MRR, so mean reciprocal rank, because I think those are more retrieval specific, and I think worth going into a little bit more. So really quickly, NDCG, normalized discounted cumulative gain, and mean reciprocal rank. They're both metrics that are focused on really not only are you retrieving the right information, but is the right information high up. So basically, the higher up the relevant information is, the better your information retrieval system actually is. Pretty straightforward. I'll talk through mean reciprocal rank is probably the easiest to go through, and getting a little bit mathy here. But basically, if in this example, let's say you have 3 documents that are retrieved, and document 1 is not relevant, document 2 is relevant, document 3 is not relevant, then mean reciprocal rank kind of takes the most relevant or the highest ranked relevant document and takes its reciprocal. And so basically, if it's ranked 2, the relevant document is ranked 2, then we're taking 1/2, 0.5 as our reciprocal rank, and kind of averaging that across our data points. Normalized discounted cumulative gain gets a little bit more mathy in that it sort of compares a discounted cumulative gain for a particular ranking against an ideal discounted cumulative gain. And so assuming kind of basically here our document 2 is the most relevant one, the discounted cumulative gain basically sums over all of our individual scores and discounts a score if it's in a lower rank. And so that's kind of by like this this division of log base 2 of the rank +1. And then it also gives a score based on the relevance, in this case, relevance of 1, and just it says, hey, like based on this sort of relevance score, what is that discounted cumulative gain, and sums it across all of the retrieved results. And then it compares that to an ideal discounted cumulative gain, which is basically, hey, if the most relevant results were at the top, what would this DCG sort of evaluate to? And basically says, hey, what percent of the ideal optimal situation is my retrieval system actually returning? So I think math-wise, it's a little bit more complicated. I think it tracks very like nuances in terms of how the ranking, like different orders in ranking, a little bit more than mean reciprocal rank, but it's very valuable in terms of just having all of that information summed up in a single metric for how a retrieval is working. Cool. So on the flip side, we talked about retrieval, and we can also talk about generation. So generation, on the generation side, I think that there's been a little, well, generation is a little bit newer in terms of how people have been using it, and in terms of how they've been sort of pushing on evaluation. And so a lot of these papers that I'm sort of referencing have or tools and papers that I've been referencing are fairly new, kind of within the last year or so in terms of development. I think there's going to be a lot more development here in terms of how metrics for generation actually turn out, and how people make the best sort of assessment on how a generative system is working. And on the Kolena side, we're excited to see those developments and keep up with them, and make sure that our testing and evaluation system works well with them. But kind of the state of the art right now is some metrics from open source toolkits like RAGS, RAG assessment, and Aries, which I think is an automated RAG evaluation system. And so kind of I've linked the two archive docs there for how they're the details in the papers, but like there are a few kind of metrics that they sort of highlight. These metrics are a sort of a hybrid in some ways between purely, well, actually, let me take a step back. Let's talk through the concept first, and then like talk a little bit about the implementation details here. Because the concepts are I think the easiest to understand. One is answer correctness, just how is the answer that's generated by the system compared to the ground truth answer, both in terms of like semantic similarity as well as like factual similarity. So does it answer the question in the way that I want it to? Faithfulness, which is how well the answer matches kind of the provided context from the retriever. So does it actually use the information that it's given? Well, answer relevantness. How well does this answer the question of the prompt, even like regardless of whether or not it's correct or not. Aspect critique, which is kind of like behavioral checks. So things like harmfulness, maliciousness, coherence. Those are things that would be like aspects of the response that aren't necessarily captured in terms of correctness, but would still be relevant in evaluating the system. And answer semantic similarity, which would be things of just comparing against a ground truth in terms of just like vector embedding similarity of just like how well does it actually match it semantically. There are from kind of other benchmarks such as RGB, there's additional tests for robustness or measures for robustness, which is this noise robustness is like how well an LLM handles being given additional information to that's potentially relevant to a question, but doesn't actually contain the answer. So for example, I'm being asked, I'm asking like who was the winner of the Nobel Prize in 2021, and it gives me context about both the winners of or Nobel Prize in a specific area, let's say literature, and then it gives me kind of both a chunk that says Nobel Prize winner of literature in 2021 was, I don't know this off the top of my head, but also gives me another chunk saying Nobel Prize in literature winner in 2022 was another person, and like that's additional information that the system should be robust to. I realize that we're starting to run low on time, so I'll try to zoom through things a little bit faster here. Cool. So outside of that, there's negative rejection. Basically, does the LLM kind of opt out of answering question if it doesn't think it knows the answer? Counterfactual robustness, how well the LLM identifies risks of known factual errors if they are retrieved. So if it's provide context on, hey, like information along this line of study has been recently disproved, please disregard it. How well can the LLM actually adapt to those sorts of systems? And then lastly, kind of a number of detailed traditional LLM or LLM metrics and traditional NLP metrics, kind of just for hallucination, blue, gel, that you can also find on our Kolena docs. So here is kind of an example of the RAGS calculation for faithfulness. I don't think I'm going to go into too much detail because I do want to make sure we have time for kind of the walkthrough and the example and the Q&A. But basically, the overall sort of situation is you get a question where and when was Kolena founded. You provide some context, and then how a hyper-faithfulness answer will be able to take that context. So started as a project late 2020, formally founded in March of the following year. Is it able to retrieve basically both parts of the, sorry. So the hyper-faithfulness answer will have multiple parts, and those multiple parts should be inferable from the given context. A low faithfulness answer should you would still break that into different parts, but the individual pieces, so December 2019, would not necessarily be inferable from this given context. And so that's kind of the logic for how faithfulness would be evaluated. In practice, and I think I mentioned earlier that I touched back upon this, in practice, a lot of the way that a lot of these systems do this are kind of the open toolkits, or I guess in areas do this sort of analysis is they do they sort of use LLMs themselves like to do this evaluation of just, hey, like let's go ahead and break this down. Let's go ahead and see this is the process for comparing them. This is the context I was given. This is the answer. Let's do this breakdown. Give me a score based on the sort of logic and based on kind of the LLM evaluation here. That's not to say you couldn't do it by hand or as a human, but in practice, like when you kind of build out these systems and you build them to scale, it becomes very difficult to scale between large across large amounts of data if you don't scale it or if you don't use an automated system accordingly. Cool. So let's switch gears, talk through the sort of RAG system for Kolena docs that we used as a sort of thought exercise as well as a dog fooding of our own platform. Really quickly, just to talk through the process here is for just doing a general assessment for like a RAG system. Like what you want to do is you want to build an evaluation data set, prompts, ground truths, as well as like the corpus of information. Put together that RAG system. And in this case, I think we used we did the whole chunking and extraction ourselves. And like I think we landed on a standard retrieval system, and then also put it through different LLMs as part of kind of the generator system. And then basically try to assess based on the metrics that were previously talked about, how well does my system perform overall? How do different versions and iterations compare? What are weak spots or blind spots in my system? How can I deep dive into specific failures? What about like building together like test cases or like different scenarios that I care about in future iterations? Let me go ahead and exit out of this. So what we ended up doing was, as a summary, we put together kind of a Google Doc type report of just we were in the thought exercise, we compared a Mistral LLM versus the Databricks DBRX instruct LLM and ran through kind of a bunch of considerations here. So practically on the practical side, cost and latency. On the correctness side, some of the correctness things that were flagged previously in the presentation. Likewise for the behavior side, basically what are specific behaviors we cared about for our specific behaviors we cared about for our RAG document, our documentation sort of chatbot, and then lastly the adversarial risks of that sort of that system. I think the details here are in general, like the form factor here was to suggest a kind of a report that you might give to an executive, as well as with links into the Kolena platform to really understand quickly understand how a model is how a system is performing when in both on its own and in comparison with another system, as well as being able to dive down deep into kind of different failure modes. So let's start with some of the correctness pieces here. I think we focused on basically 2 points here. One was whether or not the relevant answers were answered, questions were answered factually. And so we focused on correctness based on human judgment in this case, as well as hallucination score, but once also based on human judgment. I can sort of expand on this a little bit. Here is some of our here is kind of a comparison view of both the Mistral model and the Databricks model, and you can sort of see how the models compare overall, where it looks like overall Databricks has a roughly even correctness and slightly less slightly less hallucination scoring, but also a lower answer quality score. We can kind of see based on like this breakdown seems like the answer quality score is worst for Databricks, the Databricks model on like what is type questions. And so if we go ahead and click on that, we can go ahead and see situations where kind of each of our questions and look understand kind of just what is this data point, asking like the question that was asked, the answer that was the ground truth answer, as well as kind of for each model, kind of incremental pieces along the way of both here are the here's how things were evaluated, both from the human side, from using an LLM for these metrics, for using RAGS metrics, and then the additional predicted answer. And so basically this, sorry, that's the wrong tab. Basically this view kind of gives us the full-on comparison between these in terms of correctness as well as in details here. We break it down into different scenarios that we wanted to focus on. So within collapsible callouts, within tables, et cetera, as kind of different sub data sets or test cases. But I'm not going to go into those in too much detail since we're running out of time. The other thing that we did on the correctness side is assess kind of the sort of faithfulness, contextual based metrics. And so have that open in another tab. And you can kind of see here that even with our significance slider, we slid to the left because like even with like a very high sensitivity to delta and significance, like these numbers aren't significantly different. And so faithfulness and context precision are both roughly similar and both fairly high for the Databricks and Mistral models. And so kind of the summary here in this case is that both models stayed faithful to the relevant context. Behavior-wise, we ran through kind of relevant or irrelevant questions, making sure that our rejection rate was as expected. If the system handled toxic questions, if the answers had valid citations, if they followed the particular style guideline. I think of these, the most interesting was kind of the check on citations, where we can see that the citations for Mistral were the citation rate for Mistral was much higher than the Databricks model, and we can kind of see that, yeah, see that kind of the breakdown here as well in significant detail of kind of here. There's a lot of red when you're comparing Mistral versus Databricks, even when broken down across scenarios. There's one very small scenario that has very few data points where it looks like Databricks seem to have performed better, but because of the small number of data points, I wouldn't index into it too much. And once again, we can sort of dive into kind of the details here of like specific examples where this behavior came through. Sorry. Cool. Lastly, we went through sort of adversarial risks here as well. Broke it down by different types of adversarial attacks. I think I'm not going to dive into any of these specifically. Let's go ahead and just take a look at it overall, but like kind of the metrics that we're using here, or the attack success rate. How well did the like what was the success rate of the attack actually going through, as well as the refusal rate of just, hey, how many times during these attacks did the LLM actually refuse to respond because, or like back out because it knew that it was a situation that it wasn't able to handle. And in this case, we had Mistral, Databricks, as well as GPT-4 Turbo run through this, and we can kind of see that for the most part, there are scenarios where kind of both Mistral and Databricks kind of perform better or worse than each other. But it seems like across the board, GPT-4 Turbo is more resilient to these types of attacks. Yeah, I think that's about it for kind of the talk part of this or my part of this presentation. Sorry for rushing through things at the very end here. I wanted to make sure we did have some time for a little bit of QA and talking through things. But thank you all for listening and taking the time to attend this webinar. Skip, I'm going to pass it back to you.
Perfect. Thank you. Yeah, we're going to go into the Q&A portion now. So if you have questions, particularly very eager to hear if you have questions, if you're building your own RAG systems, issues that you're running into, difficulties that you're experiencing. We'd love to hear from you. We don't have a ton of time for questions. We'll get through as many of them as we can. But while people are typing those questions, just one for you here, Andrew. So we talked about how RAGs have these two components, the retrieval side and the generation side. When we're talking about evaluating them, would you recommend breaking down the evaluation into those two stages, or is end-to-end evaluation a better approach?
I think they're both valuable approaches. One gives you the sort of, hey, here is how my system works overall. But end-to-end testing and evaluation in general is difficult to maintain at like very large scales. And breaking it down into retrieval and generation kind of does give you that insight into the individual pieces and is more actionable if one of them uh, uh, runs into an issue or a failure. So I would, if I were to choose between the two of them, I think end to end gives you that whole perspective. And if you're just starting out, I would definitely recommend just like smoke testing and running through kind of how well do these scenarios work. But if you're focused on rigor, then I would also be breaking it. Like I would also like to focus to break it down into retrieval and generation.
Yeah, makes sense. Makes sense. Another question for you. So we saw the Kolena platform just briefly here during the demo. When you're thinking about using Kolena generally, how does it help when you're evaluating models? What is it about Kolena that's helped facilitating that process for you?
Yeah, I think a lot of the power in Kolena is focused on basically surfacing that information in a way that is easy to consume. Basically, when you have kind of these metrics that are extracted at a particular data point level, the answer is sort of what's next? How do we do it? And like you can do kind of a one-off analysis in like a notebook or using using like pandas in one way or the other. But then when it becomes sort of comes to becoming a little bit collaborative, sharing results with other people and making sure that kind of they have access to how this was done, and like ultimately coming to these like dynamic and live on the fly sort of analyses without having to deal with kind of your full uh, personal pipeline. That's when Kalena begins to shine.
Yeah, great. Thank you very much. Hold on, I need to shift my screen here for just a moment. Come back now. All right, great, thank you. Okay, I see we got a bunch of questions here in the chat. Let's see here. How about this one here from Tyler? Are you seeing that question presented to you, Andrew?
I see it. Yeah. So thank you for the informative webinar. Based on your experience, have you found cloud computing costs for building AI and ML systems a common challenge for clients? If so, do you have recommendations for addressing that challenge? That is a sort of very interesting question because certainly it really depends on the client. Like some teams are way more cost sensitive than others. Um, and so to some degree, yes, that has been a challenge. Um, for addressing that challenge, it I would I would start kind of just with any like the process for bootstrapping any sort of system where a lot of like you're basically like with cost you're kind of making a trade-off between um, if I build this myself or if I run this process or manage this process myself, like what is it going to cost me in terms of time? And so the time and effort and like scalability to like large systems. And so that's sort of the trade-off that you're making here. And the the thing that we sort of come to our clients with is saying, hey, like this is the sort of trade-off. Um, if you prefer kind of to manage these separately, then like this is the cost for you in terms of time and energy and like limitations in terms of scalability. And for someone who for a client that might be at an early stage that is doing some exploratory work, they might be okay with that. For someone who is just wants a system to that fully works and such, like that becomes kind of a, well, actually, we don't want that trade-off, please. Like let's go with something that is like that does leverage this cloud computing. Hope that answers the question.
Right, thanks. I got one more question queued up there for you, Andrew.
Okay. Which one?
It's by Pantelis. I'm sorry if I'm butchering the name there.
Oh yeah.
I can
Okay,
read it.
I see it.
Great.
Thank you for the one from the seminar. Approaching problems where we need to provide domain expertise in LLM from a database of documents. What approach would you have the less pitfalls, RAG or fine tuning? Thank you. Okay. Yeah. So there's definitely both trade-offs here. In terms of like, and once again, it depends on the use case, but in terms of like agility, RAG systems are like, you're able to update them a lot faster. You can kind of still have you can update your corpus and still like use the same sort of system for extracting and being more dynamic um, to like these changes. Whereas with like a fine-tuned system, because you're not combining multiple systems, you're not dealing with kind of the latency of working with this RAG retrieval as well. I think that's a pain point for a lot of teams that are using RAGs as well. It's just like ultimately like there's this latency step of, hey, I have to send this. I not only do I have to send this thing to an LLM, but also I have to run this thing through a retrieval system before I pass it over, right? And so as a result, like it depends on the use case, but the reason why RAGs are so exciting right now is because of like their flexibility, how easy it is to update, and ultimately like I feel like this technology is still in a very early infancy stage, and like the use cases need to be flexible and dynamic and be able to update to what a end user might need. And so that's why I would bias towards that.
Right. Thank you very much. We're coming up on time here, so I want to go ahead and wrap things up very quickly. Thank you for all of this, Andrew. Excellent presentation. I learned a lot as well, actually. So let me actually, I'm just gonna skip the summary or skim through the summary here. RAGs obviously are these systems to enhance outputs with information retrieval. Got these two main components, retrieval and generation. There are pitfalls you have to test against for these two modes as well as end-to-end. Failure modes, you got those ABC failure modes, adversarial, behavioral, and correctness. Those are the three areas you want to test against. Tons of metrics that you can use. Andrew talked about a few of those, but there's quite a lot more. I'll provide some resources on the next slide after this where you can get more information on those. And you can use these metrics to really improve the performance of your RAG systems. Here's a page with some of the resources that we discussed here today. First one is Kolena has an ML metrics glossary on our website. It's got information on metrics of all kinds, not just for RAGs, but for any kind of use case that you're working on. It's at docs.kolena.com/metrics. There's also put links here to the Ragas and Aries toolkits for evaluating RAGs. Super useful, lots of metrics that you can use there that we discussed. Our blog has a lot of best practice and AI quality education. So feel free to, or I encourage you to check that out in not just for RAG information, but for all kinds of general best practices on how to train and test AI effectively. Our next webinar is coming up in a couple of weeks. It's going to be me and Saad, who's been helping out answering the questions. Thank you, Saad. He's from our research team. We're going to be talking about how to enhance AI testing with metadata hydration. There's a link here. You can use this QR code or take this. We'll also try and share the slides after this talk. So if you aren't able to screenshot this right now, don't worry too much. Last thing is just another plug for our conference that we have coming up. And I want to make sure that you see this discount code. This discount code is for 40% off. It's a pretty big discount. This is coming up in San Francisco on June 25th. All of you that are attending this talk today, we'd love to have you. I think it'll be very relevant for you. We have a lot of great speakers. And you know what, if this discount isn't enough for you, let me know. Reach out to me at skip@kolena.com. I'll get you a bigger discount. I'll figure it out somehow. But we would love to see you at this conference. We're super excited about it. And that's it for this webinar. Thank you again, Andrew. Thank you all for attending, and we'll see you next time.
Thank you all.